long live the signal. We are talking about we're talking about history. There's going to be some drama, and hopefully you'll learn along the way. So, as shared, my name is Mohammed Hassan. I'm originally from Pakistan. I've been in Stockholm, Sweden for the past 5 years now. And I'm an author of three books. Angular Cookbook was my second book and my first book. So we had two editions. And my recent book is called Mastering Angular Signals, which is on Amazon now. So yeah, we're gonna talk about a bit of history. So in the world of Angular, I wish I had some reverb, but in the world of Angular, we had applications which were built on the foundations of something called RxJS. If you were an Angular developer and you did not know RxJS, you would basically fail interviews and would not get hired. This is how important RxJS was since the beginning. One of the biggest things that were around the horizon were performance. So whenever we talked about Angular, we talked about, okay, there are some performance issues that appear when it comes to large Angular applications. And this particular story of today is sort of a revolution. It's not an evolution of the same things happening. So if you talk about what has been the status quo for a long time, that was Angular with RxJS. And just like any technology, when adopted and worked with for years and years, it's really hard to get away from that. And that becomes the status quo. So let's talk about what is good about RxJS, because I really, really like RxJS. I've been working with RxJS for about 10 years now. So first of all, RxJS is a library that is mature. It's battle tested. It has been used in so many projects over the years, and especially since it also something that came with Angular 2 and then has been used since then. And I was a user of Angular 2 when it came out as an alpha, so I've been using it since then. When it comes to RxJS, it's amazing when it comes to asynchronous handling, whether you talk about events, you talk about complex streams. If you have a game that you have built with Angular that requires tracing mouse movements, keyboard handling, HTTP calls, you name it. If there are asynchronous events in your Angular application, RxJS is just amazing for that. And it also has so much of a rich ecosystem. Really, really good developers over the years have introduced via articles, videos, conference talks, so many things, so many patterns, so many libraries. And also RxJS has so many operators. If you are working on a particular situation that requires something complex, I can bet that RxJS already has an operator for that that would make your lives easier. And as I said, when it comes to complexity, whether you need to have parallel API calls, sequential API calls, calls that should cancel on a new input, there's so many things that could come in the way of working when it comes to a complex Angular application. RxJS provides so many operators for that. So I can definitely say that for a decade almost, RxJS has served us well. But there are cracks that are now showing, especially when you look at a legacy Angular application. So what are the hidden problems when it comes to RxJS? And for the questions, I would take them and at the end of the talk, so we have sort of a smoother flow. So please mention your questions in the chat, and I think we can take them at the end. So let's take a quick example of if you wanted to implement a search with pagination with, let's say, also resetting. So when, sorry, give me one second. Yeah. So when you want to do a search with pagination alongside, if the query changes, you need to also change the page as well. For example, you search for a user named Scott and you get 10 results. And then you, or maybe you get 10 results, but you have 50 Scott. Now you're paginating. You go to page 2, page 3. Now you change your query. You say Ahsan. Now the page should reset back to the first page and not remain on the second page. That's a very classic use case. For this to happen, you would have a code that looks like this. You would have a search page with the reset stream in which you are looking at the search subject. So the search subject is whatever the user is typing. If they are typing Scott, then the search subject has the value scored. If they're searching for Ahsan, then this is what they have. So you're looking at that. You're looking at whenever it changes, then it should do something. What should it do? It should go ahead and it should reset the page to 0. So you are first thing that you notice here is that you are doing a manual reset here every time. And then you also have to take care of the fact that if you don't unsubscribe from this stream, you're actually going to have memory leaks. So you need to also use take until, take while, whichever operator you prefer. I actually prefer take until, but you have a destroy subject then that needs to be taken care of. Then you have the search params within itself, in which you go and use the page subject, you have search with page reset, and then you're mapping over them. That's another subject. Then you have actual API call. So after you have done all of this magic here, then you come here and then you say, okay, this is the API call I want to do. So whenever the search query changes or the user searches something, I want to actually go and I want to make this API call. So that's what's happening here. And you're using a debounce here as well and with the switch map. So you have to have knowledge of all these things. Why are we using switch map? Why are we not really using flat map here? Because we want to cancel the call if the query changes. We are also using debounce time, etc., etc. Finally, we need to make sure that when the component destroys, we clean all of these subscriptions so we don't have memory leak. So what is the problem with this one? If I summarize this, we have manual subscription management, we have really complex chains, memory leaks, but these are the technical problems. What if someone new comes into your project and starts having a look at this code? They would be like, what the heck is going on here? Why are we having so much configuration for just one single API call? And that is a bit weird. So we have about 25 lines of complexity right here. When you talk about signals, directly those 25 lines lose 10 lines. So here you see the implementation of signal. So for search, for the variable or for the values of what the user is searching, for example, Scott or Ahsan or Muhammad, for all those values, search term is the variable that takes care of it. And this is what you need. Then if you need to reset the page, all you need to have is a linked signal. And with the linked signal, you can say, okay, whenever the search term changes, you basically reset it back to 0. As easy as that. You don't have to manually go and update the page variable again and again. And one of the nice things about link signals is that not only you have a signal coming out from there, and we are going to talk about this a bit more later, but not only you have an automatically computed value which resets to 0 whenever your search term changes, you also can manually go and change this variable as well. So you can say current page to set it to 1 or 2 whenever you're clicking the next or the previous button for pagination. You have something that resets itself, and you have the same thing that you can yourself update as well. So you have programmatic control as well as reactive control here as well, which is amazing. Then we also have things like resource here, which automatically triggers the API call if any of these things change. So if the user starts searching for something else, then this API call is triggered. And if the user changes the page, next or previous, then it also does the same thing, which is awesome because everything looks reactive now. So if you compare this code versus this code, you can immediately see which one is easier. You need to know behavior subject. Why is this one not behavior subject? Then you need to know these operators, distinct until, change, tab, take until, switch map, blah, blah, blah. All of those things. It's too much to learn, especially when you're jumping different projects at the same time in a big organization. So the benefits here is automatic cleanup. This is something I did not talk about. There is no ng on destroy needed in the case of using a signal, because as soon as the component destroys, the signal's value is automatically gone. You don't have a subscription. That's why you don't need to unsubscribe as well, which is amazing. So automatic cleanup is there. You have code that's easier to read. You have significantly less code as well. A win-win, I would say. Let's have another look at a problem. So in this one, we are talking about HTTP data fetching and the complexity of it. In the old ways, let's say if I'm trying to fetch data based on the city. So this is an example from my book in which I try to get weather information based on the city. So I have Stockholm as a city, and I think I have Berlin as a city, if I remember correctly. So out of those cities, if I change my select box, I just want to fetch the information from there. If I used observables, this is what I would do. I would go and say, hey, this city subject has the value of the selected city. So it could be Stockholm, it could be Berlin. When that changes, I want to change the loading to true, the error to null. So now I'm having to show a loader. So as soon as the city changes, I want to show a loader. That's why I have to, flip the variable for loading. And if there was error shown before, I need to hide that as well. So I set it to null. Pretty obvious. Then I make the HTTP call. So here I use switch map. Then I go with this particular API call. I hit the endpoint. If I get the data which is correct, then I set the error to null. If I get an error, then I set the error and I set the data to null. In either case, if it's success or if it's failure, I have to set the loading to false. That's the old school way of working with HTTP calls in here. So you can see a couple of things here. One, we have a pipe on the city subject. Then we have a pipe on the HTTP call. This is one way of doing this, but you could also have this pipe outside as well. But that brings more issues, so to say, and you have to make a decision there as well. But again, here we have some sort of manual cleanup for loading. Then we are also saying, okay, you need to take this subscription, or you need to keep looking at the city subject where I have the value of the selected city until the component is destroyed. So I also need to unsubscribe it. Otherwise, it's going to cause memory leaks. So if I'm on the weather page, I go on the admin dashboard or login page, come back to weather page, there's a new subscription. Then I go and come back again. This is the third subscription. So the more you go and come back to this particular page, if you don't unsubscribe, the more subscription you will have and the more API calls you will be sending, which is a classic case when we are working. So yeah, not nice. If we look at the same example from the signals point of view, this is how easy it looks. You just have a signal that has the value Stockholm. You have an HTTP resource. And in the HTTP resource, you basically say, OK, get the selected city and make the API call. It makes the API call. It gets the response. It parses it if it needs to do something with that or no. The weather object here automatically has the loading variable or the is loading variable or the signal. The weather resource automatically has the error signal. The weather itself has the value signal. Now, these are some things which were not provided by RxJS because that's RxJS, that's not Angular. But signals are being provided by Angular. So they have incorporated these variables automatically in this thing called HTTP resource, which is a resource behind the scenes. So you have these variables provided by Angular. So we don't have to create them for every single API call on every single page, which makes things so much easier. So first of all, we have dramatically less code, as you can see. So compare this with this giant. So you can see how much easier it is when it comes to working with signals. And all I need to do if I need to make another API call is just call this change city method, which updates the selected city variable. As soon as that updates, this API call is triggered automatically, which is awesome. So let's go forward. Now we are talking about the big problems, so to say, which is Zone.js. If I remember correctly, I think Zone.js has been talked about for at least 5 years by Angular community that they don't want it, and everybody wants to get rid of Zone.js. Can someone react with a thumbs up who know what the problem with Zone.js is, or how many of you know about the problems with Zone.js? Just do a thumbs up reaction, and I can see. Okay, so I understand that not many of you. So let's talk about how does Angular know it has to change something. Let's imagine a clock. So you have a clock component which shows time. Every second, it needs to show you a different time, right? So how does Angular know that I now have to go and change the HTML with the new value for seconds, minutes, hours? How does Angular know which clock component is? Similarly, let's say if you have a profile picture at the top somewhere and you change your profile picture, how would Angular know that the same profile picture is being used somewhere else and it also needs to update it there as well? So those are the kind of challenges that you would see in Angular applications. By default, Angular does not know where to go and which component to check or change. Whenever you do anything in an Angular application, by default, what happens is that, let's say the user clicks a button. Angular or Zone.js patches that event, which means that Zone.js is standing in the middle. And as soon as someone does something, Zone.js captures it and says, okay, something happened. Then it goes to Angular and then says, okay, Angular, you need to trigger the change detection. When Angular changes or runs the change detection, it goes to every single component and re-renders it to check if something changed. Let me show you an example real quick. So I'm going to go out from here. And let's say, let's take an example of something that I've uh, built for myself. So here, this is an app built with Angular and Nest.js. This is something that I've built for myself. And if I go here, you can see that I have a profile menu here. You could also take an example of GitHub, for example. So if I go here, let's say, and I change my name here, my name should automatically change from here to here as well. This one also should change, right? As soon as I change my name somewhere and I have the same name here being shown as well, it should automatically change. That is the usual behavior that you would expect. Otherwise, what would happen? You change your name here, then you refresh the page, and then this name changes here, which is not fun, which is not instant updates. So because Angular does not know what changed or where the user is interacting, is the user here, is the user changing something here, Angular has to basically look at everything. So if you imagine this search is a component, this sidebar is a component, this thing here is a component, these tabs are components, Angular basically reacts or checks everything, all the components. That's what this slides is showing right now. So whenever something happens in an Angular application, all the components go crazy. They're like, okay, something happened. We need to check what happened. So it goes through all those components, and then if their values change, then they re-render the component, which means that the HTML now has the new value. Is this efficient? No, I don't think so. This is efficient. And the reason why this is not efficient is that even if it does not re-render all of them, which means it does not refresh all the HTML in the whole application, it still has to go and check everything, which also takes a lot of time. So even if it does not refresh the whole page or refresh all of the components, it still needs to check all the components, which is the performance bottleneck, which is bad, which is essentially everybody who talks about Zone.js, they're like, no, we don't really want this. So Zone.js checks the entire component tree, even if only one components need updating. So what happens then? So the performance cost basically is something looking like this. So if you look at this example, where we have some errors that we need to show, for example, email errors, confirm password errors. Let's say the user is typing a password, and then it says repeat password, but the user types wrong or different passwords in those inputs. Then it should show this message passwords must match. Similarly, there could be a variable called isFormValid. This is 30 plus lines for one single thing, which doesn't really make sense. If we go and look at the signal approach, this is significantly less. It's like 15 lines of code. So in here, we have just a model for email, password, confirm password. We have a computed variable that looks at email errors. We have confirm password error. And then we have isFormValid. So all of these things essentially reduce the lines of code that your developers are trying to write. So far what we have discussed is observables are great for asynchronous logic, asynchronous streams, but they have problems with performance, code readability, and also the lines of code that the user has to write. If we talk about sort of the reactivity mechanism of signals, this is what happens. And whenever now we talk about signals, we talk about this term called fine-grained reactivity. So imagine me and my family in a house. Whenever something, or let's say after a few seconds, if there is a sound and everybody starts looking at each other like, who made the sound? Who made the sound? Everyone will go crazy. That is like the Zone.js behavior. But if in my family, in our house, if we know that there are only two people who can make that sound, then that means that whenever there's a sound, only those two people would be asked, did you make the sound Ahsan or did you make the sound Mohsin? So that is the example of signals. What happens with signals is that if you are using signals, Angular knows exactly if you change or not. So for example, if there's a signal called profile, if the profile signal is being used in component Z, and if it is being used in component X and it's not being used in component Y, then whenever the signal value changes, Angular does not have to take care of all the components because it already knows that the signal is used in this one and this one. So it will not even check this component. And that is where the importance of performance lies. We're not talking about rendering the component. We are talking about even a step back, even checking the component. So Angular change detection does not even go to this component and completely skips it. That, okay, this component does not use this signal. The profile changed, so only these components use profiles. So I'm just going to go and update these two, which makes sense, which is the fine-grained reactivity. So only the components that actually use the signal get updated. This is amazing. So now we have looked at the situation where we have RxJS, which is this big giant. And if you are an Angular developer, it is quite possible that your team already works with RxJS, and it's hard to get rid of, and nobody wants to, let go of RxJS. But we have three paths forward with the situation that we have right now with this status quo, so to say. So one is defend, that we defend that, okay, RxJS is the thing. We're not going to go with signals, no matter how cool they are. So we keep the current patterns. We accept that there are performance issues, but okay, we are fine with that. We love them. Or, and we also continue managing, subscriptions and memory leaks, sort of preventing them manually. And we shout, the always are the best. The other approach could be escaping, which means that we say, okay, RxJS is bad, Angular is bad. Let's just leave Angular and go to React, Vue, Svelte. They have signals, so they are pretty nice. Or we say abandon the Angular signal, or we rewrite everything from scratch, like lunatics in vanilla JavaScript. I don't know why would you do that. Or we, as we say, the grass is greener on the other side. So whatever you choose, instead of actually addressing the issue, you're going to be like, okay, that's easier. But when you go in that, you'll find that it's much harder. Or we attack. So we embrace Angular signals. We validate that, okay, there's a new way of doing things in the same framework that we like and we code in. So let's learn what signals are and basically start using those. So first of all, Angular comes with modern reactivity, as we discussed already. It gives you the best of both worlds. So even when you are using signals, you don't really lose RxJS completely. And I'm going to tell you why. You also have a gradual migration path. So you don't just go directly, on signals and you never look back. That's not the case. So even if you are using signals, or you start using signals, you can still use RxJS alongside. Again, it's evolution within the ecosystem. So let's talk about the signal revolution. So there is one thing that we have not talked about, and that was the dependent data loading. So when we talk about data that is dependent on each other, for example, you first have to get the user, then you have to get the user's posts, and then you have to do some analytics on that. Everything depends on each other. So first you need to get the user. Then you check, okay, the user's ID should exist. I'm not going to go into too much detail, but let's say you get the user first. Then after you have gotten the user, you get the posts. Then for the analytics, you say, okay, take both this user and the post and then calculate analytics. This is what you would do normally with RxJS. When it comes to signals, this is what you would do. So you can see that the line of code are not really lesser as much as the clarity of the code. So if you look at the previous example, you need subjects, behavior subject. You need to know what pipe does, what is filter, switch map, share, replay, to not really calculate it again and again. You need to know take until, manually unsubscribe it, and all this. When it comes to signals, you have just one user ID. You make the resource call. Whenever the user ID changes, you get the user. Then you have a post. Whenever the user changes, you make the API call to get the user post. And then you have a computed. Whenever the value of the user and the post change, and you have both of those now, then you calculate the analytics. The code is much more easy to learn, to use, and to tell others, especially if someone new joins your team. So we have explicit dependencies, we have automatic sort of sequence now, and it's type safe. Everything makes sense when you use signals. So now we're going to look quickly into dependency tracking. As I mentioned before, if you have questions, please just write them in the chat and then we can have a look. Now we're looking at an example of, let's say you want to have a full name signal, and you want to have it based on the first name and the last name. So let's suppose you have a form which takes input from the user as first name, and then another input that takes last name. And then down, you're showing the value of full name based on it. If the first name changes, the full name should automatically update. So what happens in general? You can essentially just create something called a computed signal based on these two signals. So you can take the first name signal and the last name signal and combine them in a computed just like this. When you do that, what happens is that it tells Angular that there is a computed signal. Then it first reads the first name, and then it tracks the dependency via Angular. It then reads the last name and then registers the last name signal with Angular as well. Now, Angular knows there are two signals that I need to look at. Whenever there is a change, so let's say the developer or the user changes the first name from Ahsan to John, Angular automatically identifies that and it notifies that the first name has changed, or the first name signal notifies that. As soon as Angular gets notified that, okay, the first name signal has changed, that means I need to notify the computed. So what happens is that the computed gets re-executed and the UI gets updated automatically and the full name gets shown again. That is amazing. Behind the scenes, a lot of things are happening, but all we need to do is just create signals and compute it. So let's talk the basics now. How do signals work? To create a signal, you just go ahead and say, okay, this variable equals signal, and then you can give it an initial value. A signal could be a signal of a number, a signal of an array, an object. You can just create a signal just like you create a variable. You can also define the type of a signal. So here I'm saying this signal can be either a user or a null. So by default, it would be null. Then you fetch, let's say, the user from an API, and then you set the user here on, say, the signal. When you want to read a signal, whether in TypeScript or whether in HTML, you're going to use the signal with these small brackets. So you basically call it like a function. And then you get the value of the signal. When you want to update a signal, you can use the set method, which updates it directly or which sets the value. So let's say if this count was 0 before, now the count is going to be 5. Sometimes you want to increment the count or decrement the count. So you need the previous value or the current value of the signal, and then you want to update or use it. For that, you can use the update function, in which you can have this sort of function as an argument, and then you get the latest value. So let's say the count was set 5 here, and you want to increment it one time. You do it like this. So the val becomes 5, and then 5 plus 1 becomes 6. This value is returned back, and the count's value gets changed to 6 in this case. So you can use the set method to directly set a value or update to actually get the latest value and then do something with that. The example that I showed you of full name looks like this. You can see how easy this is. You have a signal for first name, you have a signal for last name, and then you just have a simple computed that returns the value concatenated. Now, just by using these signals inside a computed, you have told Angular that this full name depends on these two signals. So whenever last name changes or first name changes, this gets computed again and full name will be updated. If any of these do not change, Angular will not do anything about this variable ever, which is amazing. Now let's talk about effects. Effects are something that are used for side effects. For example, you want to save something to local storage, you want to make an API call, you want to do a Google Analytics call to tell Google or the analytics that, okay, some user clicked this button or that button. So all of those things which are not related to UI updates or not directly related to UI updates or rendering, you can use side effects for that. And for side effects, we have something in Angular called effect. An effect is essentially a function which basically gets called again if any signal which is being used inside gets changed. So let's say we have a count. I want to log something on console whenever the count changes. All I need to do is to create an effect, put this console log statement inside that. And since I'm already using a signal right here, Angular will automatically call this effect function whenever the count changes. So just by using a signal inside an effect, it automatically gets called whenever the value of the signal would change. So if you want to log something, you want to save something to local storage, etc., you can just use an effect just like this, which makes sense. Excuse me. All right. So now we are looking at some advanced signal patterns. So here, when we looked at the search query and the results limit or the pagination example, this is what you would see. So you can have a search query. Let's say you have a list of users that you want to search. You type the name of the user, it gets saved here. Then you also have a results limit like show 10 users at the same time or maximum 20 users at one time. So if you change or if the user starts searching something, I want to basically reset the current page to 0. So as I shared an example before, if I'm searching Scott and I go to page 5 of the users found, then I want to reset the count or the page to 1 if I search someone else. So a simple example could be just like this. So here we have a lot of smart dependencies. This linked signal will be called whenever the search query changes. So whenever the user searches something else, the current page gets reset to 0. If I click this next page, or if I click, for example, the next button in the pagination, I can update the page to the next page. So I can go from 0 to 1, 1 to 2, 2 to 3. And that would update this page every time. If I go to previous, then it would be going backwards. I'm going to just change my camera's battery. Give me 1 second. And it should be up in 1 second. There we go. So yes, this is one example of the camera's battery. Then we have something called resource in Angular. Resource is the new way of making HTTP calls. Let's say you want to get some to-dos from an API call. You want to get posts from an API call. You want to get users from an API call. Pictures, videos, whatever you want to get. Previously, we used to use something called the HTTP client. Now we have something called resource, which can be used for asynchronous resources. So this replaces complex observables, basically. One simple example is using it with the fetch to do an API call. Now we have HTTP resource by default from Angular, but resource can be used like this as well. And this makes it easier because what did we used to do when we used Angular before? We used RxJS and we used this subscription model with that. So when we made HTTP calls with Angular in the past, we would get an observable. We would not get a promise. So I think the HTTP calls have evolved over time with different paradigms. First, in the XHR world, we had callbacks. Then we moved to promises with fetch and other APIs. Then we got observables in Angular, and now we have signals. So when you use a resource, you get signals back. And this was one of the things that was missing for a long time in Angular, that we had signals, but for HTTP calls, we only had observables. We did not have signals. So Angular implemented, or the team Angular implemented, this resource thing that gives you back signals. So whenever you code like this for, let's say, user resource, you get signals like is loading, which means the API call is in progress at the moment and we have not gotten data. If this resource has value, so if you check the value signal, that means that it would have the actual user. And if it has error, then it would be found in the error signal. So those are the signals that we have right now. If we talk about different component APIs, now we also have things like input, output. Oh, sorry. We have input, we have model. Output is essentially not a signal. I'm going to correct this slide, but output is just a way of using a function. But we have input, which replaces the older input decorators. So previously we used to define input output like this. So we had input and then we had output like this. Then we also had something called ng model, or we had a two-way data binding. Now we just have this model that does exactly the same thing. So we have a two-way data binding using model, which is a really nice integration with signals. Now let's have a look quickly at some performance comparisons. So with some of the applications that I've tested, we have RxJS approach, which is like if it's 20 to 40 lines per component, when you go with signals, it's like 10 to 20. So you can say almost half. When we talk about memory management, you can basically get rid of manual unsubscriptions. You can automatically do the cleanup. When you talk about dependency tracking, instead of using combined latest in RxJS, you can just use computed. When we talk about error handling, instead of using the catch error operator in RxJS, you can just use resources because it automatically has that. When it comes to readability, obviously with RxJS, you have so many complex pipe chains. In Angular or in Signals, you have declarative computed values. And when it comes to sort of the change detection, we have a full component tree re-render, so to say. So the whole component tree has to be re-rendered, especially if you're not using the on-push change detection. But if you're using Signals, then it's essentially fine-grained. So one of the things that you would see, and I think I can skip on this one. We have discussed this in length already. Now, let's say you're already using RxJS from before. How do you migrate to Signals? What should be the strategy? So the first thing is that you have something called interoperability, which means that you still have your RxJS observables, but you can convert them to Signal. So here is an example of doing exactly the same thing. So this one is an observable. So if this was your observable, get current weather, which is coming, let's say, from your Angular service, you can quickly convert that into a signal using the toSignal function. So you can take any observable, use the toSignal value, and then this one becomes an observable. Oh, sorry, this one becomes a signal. This you can use inside your TypeScript file or your HTML file, no problem at all. When you do this, the value or the type of the weather signal would be either the weather or undefined. So you can define an initial value just like this as well. Similarly, you can see that when we got the weather, we can essentially look at the temperature just like this. Then, so the first phase is convert your observable to signals using this toSignal value, and you can start using signals right away then. The other thing, the next thing that you could do is start with signals. So anything new that you're implementing, you can just implement a signal for it instead of just using an observable again. So in here, you can see that we have, where are you? So we have this notifications, which you can create as a signal, and then you can create a computed over that, and then you can basically drive value from there. So the first thing would be to use interoperability. The second thing would be to use signals everywhere. And then you can start using signals like full on. You can use the input, you can use the model, you can use view child, view children, query child, query children. We have resources, we have computed, we have effects. You can start using all of them. Now, when we talk about components and we talk about side effects, this is one of the biggest problems that you would see in a big Angular application, and this is really hard to avoid. Let's take an example of a theme toggle component, so something that changes the theme of your application. When you have this component, you would have a bunch of things. You would first have to manually unsubscribe, which is to avoid memory leaks. We have discussed this quite a few times now. Then you would have to have a theme subject. You would have to have a theme subject, which is a behavior subject right here. You have the types defined. You have an initial value for this behavior subject. Then we usually take that as an observable. Then we do this observable.next, which is right here. Sorry, the subject.next. So it's really weird how we coded. And whenever I implemented something like this, I was also like, what's happening here? First, we need a behavior subject. Then we need an observable from that subject. But we use this observable only for showing values. But whenever we have to update the value, we don't change the observable. We change the theme subject. What is happening here? And this would always confuse me. So in here, you can see that we are using theme right here. And we would use this theme in multiple places, saving to local storage, blah blah blah. But whenever we need to toggle the theme, we need to change the subject's value. Okay, I don't even know why we work with this pattern. Now, when we looked at signals, this is how it should look like. So on signals, you just have a signal. The signal itself contains the value. So you don't need a behavior subject and then an observable. You don't need that. So the signal has the value. The signal itself can be used with computed. So you can create dark mode, you can create theme icon, something like this. Then if you need to save the changed theme value in local storage, so you can keep it saved when the user refreshes, all you need to do is have an effect. So if you just use it like this, that means that whenever this theme changes in an effect, as I shared before, the effects function gets triggered or gets called by Angular whenever this will change. So let's say the user goes and changes from dark mode to light mode. Since that value changes and Angular is already looking at this right here, it would trigger this function. It would come here, get the latest theme, save it to local storage, update the document body, boom, done. If the user changes it again, then this would run again. So it's super easy, super readable. I basically like it. So simple initialization and also no cleanup required. So no cleanup, no unsubscription required. Everything happens automatically. Now there are some data comparisons. For example, we have polling state management. I'm going to quickly go through all of it. I don't want to spend too much time on a lot of code at the moment, but let's see if I can go forward. So yeah, now we are moving towards something called zoneless. We already have had experimental zoneless preview. I think we are now even out of it. So we should have something that is a bit more stable now. So current zone.js dependency exists still. So when there's a browser event, zone.js does a patching, Angular gets notified. We run a full change detection on all the components, and then the DOM gets updated. When we talk about signals, if a signal is updated, Angular already has a dependency graph, which means Angular knows exactly which components use that signal. So let's talk about a profile or the user signal. The user signal contains the user name, user's email, let's say user's address, all of those things. Angular knows exactly if there's a user signal, how many components are using that signal. So it has a dependency graph. Then it already knows which are the consumers, which are the components which use that signal. So it updates only those components and does the DOM updates in a surgical manner. So this is much more proficient, precise, and it's so much reactive. All right. We are also looking at some industry validations when it comes to using signals. So in 2019, SolidJS was the one or the pioneer of introducing signals. Then we got Vue.js, which essentially had a signal-like API called Composition API. Then Svelte introduces runes, which are also inspired by signals quite a lot. Excuse me. Then we had something early in the React world, which was Preact signals. So Preact signals were introduced in Preact. Then there was a version of React in there as well, or there was a sort of interoperability of React. Then we got Angular signals introduced. Then we got React 19, which or the compiler of React 19, which is signal inspired as well. So I can easily say that Angular is really revolutionizing whatever signals are doing, and setting a standard as well. So why this pattern of signals work, you can see that the community is quickly adopting all of those things. We have NGRX signal store, which is based on signals, of course. I love this. I have a video on my YouTube channel about how to use NGRX signal store as well. Angular Material is migrating to Signal APIs as well. 10 stack Angular essentially uses signals for data fetching. We have major libraries like these, the ones that I've mentioned. They are using signals. And according to a survey that was done in early, no, not early, but in 2023, about 26% of Angular developers already started using signals back then, and now they're using even more. So what are the common concerns? Is RxJS still needed? I would say yes. RxJS is still needed for really, really complex situations where signals will not make sense. So, can we get rid of RxJS completely? I would say no, especially if your application is too complex and requires asynchronous coordination. However, for majority of the things that we have discussed, like API calls, even forms, so signal forms are coming really soon. We have normal inputs, outputs, all of those things computed, effects, all of those things can be replaced still with signals. But a lot more complex situations would still use RxJS. So another question is learning curve too steep for signals? I would say signals is dramatically simpler than RxJS because I can remember myself preparing so much for RxJS for interviews, like what are the operators, uh, even I remember taking a lot of interviews of other developers where I would question them, what is your favorite RxJS operator in an Angular interview? So RxJS was so much coupled with Angular back then. And it's not really easy to learn, especially if you're using RxJS. It's mostly when you have complex situations, and then it becomes more complex because of RxJS as well, or learning that knowledge. So here we have 125 plus operators from RxJS that you need to learn. And when we talk about signal APIs, it's more or less, 8 or 10 core functions. Might be a bit more, but let's say 20, not more than 20, right? So I would say signals are really easy to learn. So this is like RxJS and using a debounce. I have a video on debounce myself as well. So here is RxJS doing a quick debounce, and this is signals. Super easy. What about breaking changes? I would say there is a really cool migration story right here. You can just start using toSignal, as I mentioned, for the interoperability. RxJS is not going anywhere. There are new APIs that are coming in, for example, signal forms, etc. And we also have long-term support as well. So Angular, at least Team Angular, what they've said is they're still planning to support RxJS for a long time. So, what are some success stories? I can quickly skim through this. No, we can move forward. So, this is what I want you to think and basically go with. So, when we talk about the new sort of city of Angular, this is how it looks like. So, you have Rx streams that you have for complex logic. You use toSignal to essentially convert them to the signal, or signals are computed, and then you can create computed directives from there that can be used from the template or the component UI. Similarly, from that signal based state, you can have reactive effects for side effects. So I would say still, if you have RxJS streams, basically convert them to signal and then start using the signal wrappers or the signal components from there. So these are the things that you could do today. Replace one behavior subject with signal. If you have an Angular project, try this out. Try to get rid of one combined latest in your code, or this operator in your code, with computed. That would be really fun, trust me. You can also use toSignal to bridge an existing observable. You can also build a new feature with the resource inside of the HTTP client or switch map. You can also replace the async pipe with direct signals call in templates. And you can try to measure the performance as well, how it looks like. So these are some learning resources. You can go to angular.dev, search for signals. You'll find those. You'll also find examples right here as well. And there's also Angular Discord as well that you can also find. And if you're interested, you can try to find this book called Mastering Angular Signals. This is available on Amazon. I think so far we've had like two people have given some ratings right there, and it's like it's 5 stars so far, and I don't know both of these people. So yeah, it seems like the book is doing pretty good. And I think just this month, this was launched 2 months ago, and I think this month we have sold more than 30 copies. So people are buying it. So when you get the book, you get to learn all of these things. And the examples that I showed you, you actually have GitHub project, which is public, by the way, even if you don't buy the book. So it's an open GitHub project. You can go and see the examples yourself. But if you get the book, then you understand it step by step and with the diagrams and whatnot. Blah blah blah. I'm gonna quickly move forward. So yeah, I'm gonna go with this as well. So yeah, these are some of my socials. I'm gonna show you a link that you can essentially scan from your camera. What this would allow me to do is to look at your feedback directly. So when you scan this, you'll see a questionnaire on how this talk was, and you'll also find at the bottom some links as well. So you'll find the link of the book as well, so you don't need to remember or search yourself. And you'll also find links to my socials as well. So if you want to look at some YouTube tutorials, you want to see my GitHub, there are about 1400 people who follow me on GitHub. So you can see my projects and what I'm working on, etc., etc. So I hope this was useful. I think I'm gonna stop talking and take any questions you have.
Yeah, hello, Mohammed. Thank you very much for that. It was really a wonderful presentation, and it was also a technical talk. So when we put out the invite for this, we called it a technical talk, and yeah, it was definitely a technical one. So thank you very much. I would like to ask if there's any of us who have questions on maybe Angular and the topic that we discussed today. So if there are no questions, so I would like to ask if there are questions, but if there are no questions, then we can go ahead to general questions. Any questions on Angular or signals that we discussed? Okay. Yeah, so any other general questions? So it would be nice to ask general questions because the speaker we have now, so I'm just going to turn off the recording. So the speaker we have is